Hi students, welcome to the session on divergence. In this class we see the meaning of divergence, the significance of divergence, how divergence is useful in our subject. Right? So first let us define what is divergence. Divergence is nothing but a measure of flow of a vector field. Flow of a vector field. Right? So that vector field may be a flow of liquid or flow of gas in a tube, right? So you can find how much of a liquid or gas flow through a tube, right? That is given by divergence. In our subject, it is talking about flow, how much of electric field lines passing through a surface or region, right? So if you want to measure these things, you can use divergence. It may be used to measure simply a spread or convergence. Sorry. Okay. Now we will define divergence. Right? Divergence of a vector field is defined as, suppose it is a vector field is D. We can define divergence of vector is nothing but del dot D, which is given by in expression del dot D is equal to limit del V tends to 0 closed integral d dot ds divided by del V, which is nothing but divergence of a vector field D at, so divergence of vector field D at any point, that is very important word, at any point is given as the outward flux per unit volume, outward flux per unit volume as the volume about the point, as the volume about the point shrinks to 0, right? So the volume about the point shrinks to 0. This is known as divergence. You see, it is outward flow of flux per unit volume. That means flux we know, that is flow of something, right? This right? So it is outward flow of flux per unit volume as volume tends to 0. You see, the expression matches this. See, we know that integral d dot ds is nothing but our flux. If you have any doubt on this, please refer my video on surface integral. So this area, this point is known as flux, closed integral d dot ds. Divided by del V is nothing but volume. You see, now we compare. Divergence of vector D is defined at particular point, is defined as the outward flux per unit volume as the volume shrinks to 0. Right? About the point, volume shrinks to 0. Volume shrinks to 0 indicates del V tends to 0. It is flux per unit volume. Right? That's what divergence about. Okay. Let us go in depth now. Let us define on vector D. Right? D is given by dxax plus dyay plus dzaz. We know what is del. Del is dou by dou x ax plus dou by dou y ay plus dou by dou z az. Right? If you find del dot D, what we get? It's a dot product between del and D. So if you take a dot product, you will get dou by dou x dx, dou by dou y dy plus dou by dou z dz. Right? So from this, what we are understanding, yes, it is clearly understood that divergence of vector D provides a spatial variation of vector. Provides spatial variation of D along x, y, z. You see, divergence of vector D is providing what is the change in that vector along x, what is the change along y, what is the change along z, what is the dou dx by dou x, change of dx with respect to x. That's what change along x. So we can find spatial variation because we know that del is a spatial operator. So divergence gives spatial variation of the physical quantity. That D may be, for our subject it is electric flux, right? So now we see that we have to conclude some important points gathered from the divergence. First thing is, if del D is positive, divergence is positive. If divergence is positive means what happens, right? It will be like that. So divergence is defined with respect to particular point. So first let us write that point. Divergence delta D is defined at particular point. That means we can find divergence at particular point. Okay. Next, suppose if del D is positive, del D is positive means what is the meaning? It is outward flow from the particular point. If it is a point, at this point divergence is positive means the vector is flowing away from that point. Right? Here, this is del D is positive. If it is a D vector is represented by this arrow mark. Similarly, if del D is negative, if del D is negative means what is the meaning? With respect to particular point, the vector is flowing towards the point. Right? So, this is del D is negative. Next, suppose if del D is 0, right? So it is not going towards particular point, it is not coming out from the particular point, simply it is flowing, right? This is what meaning of divergence when we get positive divergence, negative divergence and zero divergence. See, from here you see that here at this point we found divergence, the vector is spread, right? Because divergence is used to measure the spread. Here it is going away. That means when we get something come out of from there, if there is a source, we will get something is coming out from that. Suppose we have a water source there. If we dig it, the water will come away. So if something is coming away means there is a source present. So at this point there is a source. So divergence, positive divergence indicates presence of source, right? So positive divergence means it indicates presence of source. Similarly, you see divergence is negative means everything going towards that particular point. Hope you see our sink. Sink, what is that? If you pour a water into a sink in our kitchen, all the waters will go and will be collected at that point, right? So sink is a collection point. If there is a negative divergence, all the vectors will go towards particular point. So it means that there is something to collect that vector. So it indicates presence of sink. Negative divergence indicates presence of sink. Suppose if divergence is 0, there is neither source nor sink. There is no source to release a spread of the vector, or there is no sink to collect the vector. Simply there the vector flows. Here it is a flow. Here it will be originating, here it will be collected, here it will simply cross, flow, right? That is very important terms to be noted. Positive divergence source, negative divergence sink, and zero divergence it is flow vector, right? So next thing we have to remember is in a pictorial form we see that the vector will be like this, right? So if your vector field is like this, right? So what is this? Here you see, okay. Here you see the vector is changing. Here it is small, somewhat bigger, right? The vector is changing, or change in the vector is in the direction of vector. is in the direction of vector. You see change in x direction. This is what, if you write it in x direction, this is x direction. You see this is small, bigger, biggest. So the change occurs along horizontal direction. That means x direction. So change of the vector is in the direction of the vector. Vector is also pointing towards x direction. The change is also in the x direction. So if the change of vector is in the direction of vector, surely it will be a divergence vector, divergent vector. So you see, if you keep anything here, it will be pushed by that. It won't rotate. It will be spreading. It will flow, right? That's what your divergence means, right? So it is very, very important. Okay, next thing I want to emphasize here is, here we apply, suppose if you apply, this is a force, means this will push that. Suppose it is a differential force, right? Here you see some less force, some more force, most force. So here differential force, but the force is force and vector acting on the same direction. So it is pushing, it is a divergence, right? Here you see, here also we see same force, but along the same direction. Even if you keep any object here, it will also be pushed. Again, it will produce divergence only, right? So this is what we have to remember about divergence, right? So what I want to emphasize here, if for a volume with surrounded by surface, as we have done here, right? In the equation you see volume enclosed by a surface. Now we come to the conclusion. You see, when volume tends to 0, here del V tends to 0, the flux will be released, outward flux. You see, we can give, this is the best, puncture tire will be the best example to define this equation. Why? You see, the volume tends to 0. When the tire gets punctured, the volume of the tire will be tending to 0. At the same time, air will come out. That is what your flux. So it is spreading. So air is coming out means this is acting as a source. That's what delta D is positive meaning. So it's a best definition. This simple equation can be analyzed or realized in this punctured tire, right? Del V tends to 0, closed integral d dot ds, which is a closed loop, right? It's a volume, tire is a volume, closed surface. This black, the tube is a closed surface, right? So closed surface, in that surface only the flux will come out. That's what d dot ds is coming out of the closed surface. That is, flux is coming out of the surface, right? So that's all about divergence. If you have any doubt, please ask me in comment section. Thank you.